Am I clear, bro? Okay. So for this module, we have to go with more explanation. Like there are many photos in these lecture, so those are more mainly useful. So I will go with them and some videos also. So listen to me. That is the most main part of here. So nothing to explain with drawing or something. So in the start, so what's the nomenclature of the automotive technology? It's just a history. So just know nothing to go through it deeply. So if you want to know anything, just read it. Read it. So if it's the history is like more, I will go to the lecture thoroughly. In first, we have the typos vehicle. That is also a bit like common, and the automotive layouts is the main. Here, the layouts are mainly categorized into three: front engine, mid engine, and rear engine, with where we put the engines for our automobile. So in the front engine and mid engine and rear engine, we have three more categories like uh, front engine and front wheel drive. It's wheel is driven by the vehicle is driven by the front engine, front wheels, and vehicle is driven by the back wheels, or vehicle is driven by the all four wheels. Commonly, we have that we don't have a rear engine and four wheel drive commonly. Maybe it's in tanks and some other military vehicles. Other than that, we don't have that rear engine and four wheel drives. And mostly we use rear engine front wheel drive. Sorry, rear engine front wheel drive is not. Uh, we don't actually it is not available exist. And mid engine and front wheel drive, it is also not exist. Rear engine four wheel drive, that is least, and other categories are there commonly used for with the purpose we have to use, like for if you are using for um, economical purpose. Economical mean for efficiency, we will mostly use front engine front wheel drive. If you are using for a sports or something else, we will mostly use the rear engine or four wheel drive. If you are using for drifting, we use a rear engine. If we are using for racing and some other kinds, we will use O four wheel drives. And for off road also, we use O four wheel drives. Oh, that can be changeable. So in here, the next is the engine and wheel alignment. So the front engine, front wheel drive, there are two types. In here, if the crankshaft axle, here this is the axle of the crankshaft. Uh, Here this is the axle of the crankshaft, and this is the axis of the wheel. If those are in parallel, it is called transversely mounted. And if the engine uh, if the engine axle is crossover to the wheel axles, it is called longitudinal model. So here, for those are mostly common. So for the transversely mounted engine, mostly we can see in inline force. Every inline force are like this most commonly, and but in uh, buses and lorries, mostly inline six is used, and it is mounted as longitudinal mounted. Mostly in longitudinal mounted, V8 boxes are mostly longitudinal mounted. Then I saw some questions about these front wheel categorization and the advantage and disadvantage. I will go through that mostly here. Okay, I have a comparison. I have made a comparison on how these are advantageable and disadvantageable compared to one another. So it will easy for you to go through that. I will share that. Uh, Here we will go through as every component. how it's advantageable for the layout, or it is disadvantage. If I'm not clear, stop me and ask anything. If you want me to go detail about it, you can ask also. But because there are more sections here, so I will go fastly as I can. So we have to finish it. Here we will go through here made comparison. So we will go through that comparison. That will be easy, very easy to. Uh, when we find about front wheel drive, we actually mostly these are the used common types. So Lihil sir has compared these four only. Others are not compared because maybe the commercial purpose uses based on these four mainly. So front wheel drive, front engine, rear wheel drive, rear engine, rear wheel drive, mid engine, rear wheel. Here, the mid engine is like not the engine is only at the mid of the engine, mid of the vehicle. So, mid engines mean the engine is actually middle in between the middle of front wheel axis and back wheel axis. It's slightly near to the rear wheel axis actually, because we need space for driver and passenger also. Mm. But like if you see Mercedes AMG and maybe Mustang, which have a long bonnet, those are mid-engine rear-wheel drive vehicles where the passenger seat is uh, behind the engine. So it's very rare. It's only in fancy cars. So when we go through the weight distribution in front engine, front wheel drive, the engine and transmission and everything is in front part. So it's the front is heavy. That's a little bit advantage. I have noted the advantages as cross and disadvantages cross and advantages click. So uh, for the front engine and rear wheel drive, there will be a shaft, couple of a shaft, and maybe the transmission will also at the mid of the engine. If I saw something mm, here, front engine, rear wheel drive. Here. The engine is here and the transmission will be here. The propeller shaft will be here. So the weight will be a little bit arranged evenly. So it is balanced mostly 50 to 50%. And when it's rear engine, rear wheel drive, the engine will be at the rear and the transmission and everything will be at the rear. It is same as like mid engine. The rear engine for the Volkswagen is the rear engine, rear wheel drive, mostly used vehicle. Here, the engine here. Here, you see, this is the axle which goes to the wheels of the car. And this is a V engine, but mostly Volkswagen use mainly boxer engines. Uh, and when we go for the mid-engine rear wheel drive, the engine is at the mid and the center of gravity will be at the center, and it is the weight balancer is like nearly 50 to 50 perfectly. But the balance in front engine rear wheel drive is nearly 50 to 50, not perfectly. Then we go for the complexity, mechanical complexity in front engine, front wheel drive, and rear engine, rear wheel drive, we don't need a drive shaft. So we can directly connect the transmission to the wheels. So there's a we don't need that weight loss there. For front engine rear wheel drive, those transfer shaft and differential may be little more complex. For mid-engine rear wheel drive, the complexity is like cooling. So for rear engine and rear wheel drive, this will also come for rear engine rear wheel drive, because when the engine is at rear, when the engine is at front, so we can, with the wind coming in, we can cool it easily. But if the engine is at rear, we have to make some any other aero parts to go through flow the engine to from underneath or side parts from the car to cool the engine if it's naturally aspirated, or even if we use liquid coolant, we have to cool the radiators also. So we have to get extra path for the airflow. So that is a little bit complexity here. Here the power transmission loss. The loss will be very low in front engine and front wheel because the mechanical complexity is less. So mechanical loss will be less. So the power loss will be less. And for rear wheel drive, front engine rear wheel drive, if the mechanical parts are low, so the power loss will be high. Same as that for rear engine rear wheel, it's low, and mid engine it's near the low, so it's low. When we go about traction, so if we think about traction when we climb up a hill, so for that, uh, if the engine is at the front, if the engine is at the front, and when we are climbing a hill like this, and for here, the engine is at the front, so the weight will be distributed here. And for the wheels, the traction will be, the weight acting on the wheels will be low. The weight is distributed here, transferred here. So the weight acting on the wheels will be low. So the traction will be low. That's why the traction for front engine front wheel drive is low. But for when the engine is at back or rear wheel drive, especially the axle, the engine is before the axle. So the weight will be slightly over the axle. So the wheels will get more weight and we will get more traction. So that is an advantage in rear wheel drive cars and vehicles. When we go with handling and stability. So in front wheel drive, when we try to steer, like in front wheel drive, the every weight will be in uh, distributed to the front wheels. When it's going straight, and if we try to steer, when we turn the engines, but with the weight and the moving as in front, for that momentum, the even though when we if we turn the wheels, like even though this is the wheels and axles, it's going fun. Uh, when we are going straight, it will be like this. When we turn, we are turning here, even though weights are, because of the weights are here and the momentum of here, the actual force will act in front. So it will try to understeer. Understeering means we are trying to steer, but it don't steer. It will go in front. You can actually feel it when you turn the vehicle and fastly put the brakes. It will slide and go away like that. So it will tends to go in front. That's the disadvantage here in front wheel drives. So in rear wheel drives, that will not be seen. So for the steering penalty, understeering is the main disadvantage here. And rear wheel drive. So here oversteering. Oversteering means we try to steer, but it steers more than we need to steer. That is like oversteer. For if we think about when the think about the whole weight is on back, so the like little bit the front wheels are lifted up, so the front wheels don't get enough traction and friction to turn the vehicle. So even though if you ride the bicycle, if you do the wheelie or something else, so you can feel it that even though we are turning the wheels when we are doing the wheelie, uh, the vehicle is not going to turn like that. So the like that. So in rear wheel drive, that is a little disadvantage. When we go with steering wheel, it's easy and light. Okay, responsible. Poor. The steering wheel is poor because the wheels are lifted up little bit. And for yeah, the mid-engine rear wheel drive, the weight is evenly distributed. So the steering and responsive will be evenly distributed for all wheels, four wheels. So it is more sharp and responsive. That's why we are using mid-engine rear wheel drives in performance vehicles. And passenger side, you'll know passenger space, cooling efficiency. So cooling efficiency is the main part here. For the front wheel engines, we'll have the radiator in front, and so this one actually front wheel. Mm. Yeah. So we will have the radiator in front. With every air intake, we can cool down the engine easily. But for if the engine is at the rear, we can cool that down that easily. So that's a disadvantage uh, when comparing it. Usually, this comparison is asked in the exams mainly. Uh, for maintenance means if you have more parts, the maintenance will be high. If you have less parts, your maintenance will be low. The weight of the vehicle, when you are having low parts, the weight is low, and when you have, you can reject the noise and vibration. So if the engine is near the cabin, so we will feel more noise and vibration. So noise and vibration is actually mean like we are hearing it inside the cabin or not. So it's based on what we have, what we are driving. If it's a normal car or no old car, there will be noise and vibration more. Driving behaviors. So for mostly the driving behavior for the front wheel drive, it's easy to control because the engine is at the front and we get more understeer. Even though if slipped more, it will go straight, and when we are using brakes and other things, so it will make us stable to stop easily. But if in mid-engine and rear wheel drive, even we steer a little bit, there will be a change in direction for the vehicle. So if we oversteer or understeer it, it will try to spin because the center of gravity is at the center for the mid-engine rear wheel drives. So actually, we can take a pause. A pause. Uh, in a race, the once in a race, the Porsche is like spinning and get into another Porsche top of it. It was like perfectly balanced. They even made an ad because of that, with that perfectly balanced. So if, in a small turn, it will make a big difference for that. That is a little bit disadvantage, but when you are under control, when you have a professional, that's a little bit uh, we can remind that. So these are the main comparison here. So I will share this in the group after this. Uh, if you have any doubts in this comparison, you can ask. Anything unclear, or I have to remind it some more quickly, or am I going fast? Is it okay? So we have finished the first one. So it's a little bit. So nothing to go more. That so you can see this comparison shot. I will share it. So shall we go to the next part and the engines and other things? So in here we have to go deep. So you can ask anything here. Shall we go? Do you have any doubts there? I will some time. So I will share this chart and you can see if there are any doubts, ask me. Is it okay, guys? Shall we go? Am I audible? Ah. So the next is the working principle of engines. Here, the engines are what is basically a heat engine is like that converts the heat engine, heat energy into a mechanical energy. That is a heat engine means. We categorize these engines as startly we used internal combustion, external combustion engines, and now we are using internal combustion engine. External combustion engines mean we are doing the combustion uh, outside the mechanical parts. Actually, we are heating up the water, and with the steam, we are doing that mechanical work. But in the internal combustion engines, the combustion is inside the mechanical parts, and the mechanism is happen inside it with the combustion. That's what internal combustion engines and external combustion engines. So in automotive, we classify it as ignition systems with two and strokes. So ignition system mainly categorized into spark ignition and compression ignition. Spark ignition means we are using a spark plug, the plug that gives a spark to do the combustion. In combustion ignition, we are just using the compression of air and fuel to fire the fuel. Um, and with this number of strokes, we have two stroke, four stroke, and now six strokes also. Uh, uh, we here go mainly go with two and four strokes because these are widely used now. So we'll compare the spark ignition and compression ignition here. I will go with all like comparison because most of it the questions are like compared to each other. Uh, in spark ignition, so the mainly it is categorized as how it's fire the fuel. So spark, we use the spark plug to fire the ignition. In compression, we are using compression and pressure to fire the ignition. Here in spark ignition, we mostly use petrol. The reason, so for using petrol in spark ignition and using diesel in compression ignition is that so petrol means in the I will come it because we have to go for the compression ratio and I will come. The compression ratio means the total volume. And this is the total volume of the cylinder is to the compressed volume of the cylinder. So actually we calculate this as the clearance volume. This is the clearance volume, and this will be the total volume. We usually take the clearance volume as 1, and we calculate the total volume for its ratio 1:2. Mostly ratios are calculated like that for the engines every time. Here for the spark ignition, the compression ratio is between 16 to 40, but for the compression ignition, uh, 14 to 25. I will come to that why it's 16 to 40 and here it's 14 to 25. So the main reason is like we are with the uh, fuels we used. Here we use petrol and here we use diesel. For petrols, actually, the petrol is more volatile. Volatile means it's easy to evaporate. And for diesel, it's less volatile. So it's more, it can't be easily evaporated that much. And the another reason is flame speed. Flame speed is like if the speed of catching fire, you may seen that petrol, if the petrol catches a spark, that will spread easily fastly. These are the main two reasons why we use petrol in a spark ignition and diesel in a compression ignition. Now we come to the compression ratio. Because of we are using petrols here, uh, the petrol is volatile and the more volatile. So it can be easy. So I forgot to tell one thing. In spark ignition, we are actually releasing fuel plus air mixture. This is one of the main difference here. In compression ignition, we are inserting fuel for the uh, compressed air. Actually, here in the when when the piston comes to top dead center, the air intake is compressed fully, and when the it comes near to the top dead center, we are releasing the fuel there. But mm, for the spark ignition, we are mixing the air and fuel first, and when the piston reaches to top dead sensor, we are releasing the mixture. So that is also the main difference here. Uh, Here, for the usage of petrols in a spark ignition, that is our main. That is also a main. When we use more compression ratio, we can get high efficiency. But we can use more compression ratio in petrol engines because the petrol is more volatile. So if we compress it more, the for the pressure, the ignition temperature of the petrol will be reduced, and it will catches fire before even before the piston reaches here. Uh, Even though we are releasing the fuel plus air mixture inside when the piston comes to top end sensor center, if there is any remaining fuel or because of the valve problems, it will make the engine knocking. So that will be a problem here. So we are using reducing the compression ratio. That will reduce the pressure. That will reduce the temperature of the inserted gas and fuel mixture. So the only thing to fire up the engine is spark. So that is a safe mechanism. Here for diesel, that is not a problem. So for the diesel, uh, it is not more volatile. So we need when we release the diesel to the compressed air, it won't catch fire that much easily and fastly. So we can do the compression more and for the diesel and make the temperature more, and we can do that for the diesel engine. That's why petrol engines are used in spark ignition and diesel are used in compression ignition. Actually, for spark ignition, there is some engines like old motor pumps that use spark ignition and diesel. For that, we for those engines, mostly we use petrol plus air mixture to start the engine, and the engine will be running on the diesel. There are like two-way systems also there. Anyone have doubt in this comparison between spark ignition and compression ignition? We will go to the uh, table also. Do anyone have doubts in this section? So just now what I said here. Um, so those are the main points. So I will go through with the this chart for a quick comparison. So when we compare spark ignition and compression ignition, the ignition type of ignition is done by spark, and here it is done by self. So most used fuel is petrol here diesel, and here we are using air fuel mixture before it's entering the cylinder. Here air is compressed first, then fuel is injected. Uh, so is it okay to go with the video? Do you guys need to show the video? The videos are likely from the lecture notes. Or shall we go without the video? It will be more clear with the video. And so you'll understand when we come to the slow stroke and slow stroke with the videos. Here, the we'll go continue the chart. So I will show the video with and explain it with the two-stroke and four-stroke also. Compression ratio here it is slow because uh, petrol is more low. Petrol has low auto ignition temperature. That's because of that. If its pressure is compression ratio is high, pressure is high, the cylinder temperature will be high. Therefore, petrol will auto ignite. That's a problem. That will be a problem here. In here, the compression ratio is high. Uh, Third down cycles in spark ignition, auto cycle. Here, diesel cycle. Thermal efficiency actually it's low because the compression ratio is low. Here it's high because the compression ratio is high. Uh, Stroke length, it's uh, it's go with the compression ratio. Means the volume like so the stroke length also short here long. Engine weight, here the petrol engines are lightweight and the diesel engines are heavy structured because we have to withstand the large pressure and temperature. That's the main reason. And here's another thing, like why the power is more in diesel compression ignition engines than the petrol spark ignition engines. The torque is high because there are two values here. Uh, Calorific value of petrol and calorific value of diesel are slightly same. So it's just 300. So we don't going to get more difference since that. When we consider the density of diesel is like 150 kilogram per meter cube, 160 is actually high. So we are calculating the efficiency based on the volume. So for 1 cubic volume, we have more diesel, more mass of diesel. when we get more mass of diesel, when we ignite it, we will get more energy from that. So, and the compression ratio is also high. So, more high number of high volume is going to compressed and powered, and the mass is also high. So, when the those mass is high, we get more power, so we get more efficiency. That is also a reason for the high efficiency of diesel engines. Mhm. And one another is stroke length also reason for the low torque here. In petrol engines, stroke length is low because the stroke length is compression ratio is low, and the when here. Mhm. In petrol engines. So this is crank, and this will be the radius. So this is the piston here. Mm. So because of the compression ratio is low, the movement of the stroke here is low. Because of the movement of the stroke is low, the radius will be less. Because of the radius is less, the torque is equal to F into R. So we are getting low torque because of the compression ratio is low, because of the stroke is low. That's why we are getting low torque in petrol engines. For the diesel engines, we get high torque because the compression ratio is high. If the compression ratio should be high, the stroke length, the piston traveling length should be high. This is the piston. This length should be high. So we will get more radius of the crank to rotate, and we will get more torque from that. Mm. Okay. And petrol gives low emissions because the like the density and mass of the petrol and carbon content of the petrol is low. So we get uh, low emissions, and in diesel engines we get higher emissions. And when we come to the noise and vibration, because of the pressure and the parts that are highly made, highly quality made, it's more noisy and vibration because of that we are using pressure to ignite the engine. So starting characteristics here, it's easy to start with the spark. So we are giving easy fire to the fuel. Here, cold start issues happen because we have to we have to heat the cylinders first. So in some cars, there will be an external circuit to heat the base of the engine. Mm. Oh, we have to do the cold start many times. So we have to rotate the engine to make it heat to come to the ignition temperature of the diesel. That will be a disadvantage here. The starting complexity in cold starts. Uh, Maintenance, it's easy to the petrol engines. It's complex in diesel engines because we have to adjust those levers and things when we maintain it, so it can withstand the pressure and uh, temperature without leaking. Fuel cost is high fuel cost, but when we consider it, it's better mileage because it's giving more power and efficiency. Power to ratio, weight ratio, it's high. Here, even though the power is high, the parts which are engine made also weight. So it's more high. So the power to weight ratio, it's lower here. So when we come to the heat balance and work useful, So most of the works here, the power in diesel engines, uh, we are getting more efficiency because of the weight and power gear getting from the mass of the diesel. So we get more work from that. Uh, Actually, the 70% will be released as heat mostly. So waste will be there high, even though it is lesser in diesel engines. So this is a quick comparison. Anyone have any doubts in here? Anyone have any confusion in why are using petrol in spark ignition and compression ignition, or any comparison between these things? So I think I have covered whatever Nikhil's said extra points also. Mm, compression. And there is one more disadvantage if we increase the compression ratio of a petrol engine. If we increase the compression ratio of petrol engine, like before I said, it's more volatile, so it will catch fire easily. So it will make to make to do the combustion before the is if it's the piston before it's reached the top dead sensor. That is called engine knocking. And even if the temperature and air is temperature is high, the exhaust gas of the exhaust gas temperature also high. Because of that, the high temperature, the emissions will be high also if we increase the compression ratio. With this compression ratio, the emissions are low. If we increase the compression ratio, the temperature of the exhaust gas will be high. When nitrogens and other gases react with it, the emissions will be high there. And yeah, that's so he had said also. Another. Do you have any doubts here? So anything more? Then we can go for the two-stroke and four-stroke. Combustion slides. The efficiency later noise, yes, noise. So it's compare and two-stroke and four-stroke. Okay. Do you have any doubts here in spark ignition and compression ignition? If anything unclear, you can ask. Am I going little fast? Am I going fast? I think I'm telling it fast and everything. Actually, these comparisons are more asked in the questions. Mostly, I have seen some pictures. So, shall we go to the two-stroke and four-stroke? Here, we'll go to the uh, two-stroke. So two stroke and four stroke. We'll see the videos first. Uh, so I will explain it first and tell the video. So we'll compare the two stroke and four stroke first. In two stroke engines, it's called two stroke because for the one rotation of the crank, for the one cycle of the combustion, we use only two strokes. One stroke means the piston is moving from TDC to BDC. That is one stroke. Here, for the one combustion cycle, we are using two stroke. That is because it's called two stroke. For in four stroke engines, we are using four times. For the piston is moving four times. For the intake, it comes down first. Then for the compression, it goes first. At third time, the combustion happens, and the fourth time, the exhaust happens. So that is two stroke, and four stroke means four times the piston is moving up and down. For when we compare it two stroke and four stroke, here the first we think about the intake. Here we actually using air and fuel mixture only. Here we are using air fuel mixture with oil. So I'm basically going with the comparison, so that will be easy to understand. Uh, we are using air, fuel, and oil here. In four stroke, we are using air and fuel only. For the when we consider about the cycle, when the intake happens, the compression also happens here. But for the four-stroke engine, intakes happen separately and compression happens separately. Here, there's a intake valve here. This is the intake valve for the two-stroke engine. Basically, for two-stroke engine, intake valve will be slightly down than the piston, like combustion chamber. Here, the intake valve is upper above the combustion chamber. That is also a difference we can identify with a two-stroke engine and a four-stroke engine. Here, when the pistons moves upwards, there will be a vacuum created inside this chamber. It's like engine case here, down case of engine. Because of the vacuum created, the pressure difference make the valve to open. So the air and fuel mixture will come inside. For the four-stroke engine, intake happens when the piston moves downward, and there will be a vacuum created, and intake valves also open here. So intake happens when the piston moves downwards, but intake happens here when the piston moves upwards. And here at the same time, combustion happens. Here, combustion happens separately. So when the combustion happens and when it comes down, the intake air and fuel mixture will go through this valve to the combustion chamber. At the same time, the exhaust gas will be go out. So here intakes happen separately and intake valve will be open. For the compression, intake valve and exhaust valve will be closed. It will compress the air. When it comes to the TDC, it will fire up the fuel and piston goes down. It will do the power stroke. Then it comes up, exhaust valve will be open and it will release the gas. So there's a effect called scavenging effect. Scavenging effect means in here in two stroke, the intake gas here which got inside the chamber will push down the exhaust gas to go out. This effect, this process is called scavenging effect. It's mainly happening in two-stroke engine. Here, when the combustion happens, this transfer port and exhaust port will be closed by the piston itself. That is also a difference between these. So, we'll see the video, you'll get more idea about it. Okay, this is two-stroke. So, can you see the video? So, let's see. Ask me anything if you are not clear in this video also, so I can portion explain it more detailedly. So the video's audio, my video audio. So
Similar to four-stroke engines.
can you hear it now? Can you hear me now? Uh,
The construction is similar to four-stroke engines. The two-stroke engine has one piston. The crankcase is used for the gas exchange.
This is the base of the engine, and this is the combustion chamber. Cause- This is mainly called as the combustion chamber, where the combustion happens, and this is the transfer port. This is the transfer port. This is the opening valve where intakes happens. This is the exhaust valve. Okay.
Spark plug as well as intake and exhaust ports.
Here, when the intakes happen, the exhaust also going out. Let's see.
A crucial difference is the presence.
And when the gas moves to the intake, the exhaust happen. Now, when the intake happens, sorry, you're seeing the beginning. It's confused.
The construction is similar to four-stroke engines. The two-stroke engine has one piston. The crankcase is used for the gas exchange. There are also a spark plug as well as intake and exhaust ports. A crucial difference is the presence of the transfer port. Let's take a closer look at the individual strokes. In the first stroke cycle, a fresh fuel-air mixture is drawn in via the intake port. It is shown here in red. It is added to the existing mixture in the crankcase. At the same time, the mixture is compressed in the...
Here, when the intakes happens and the piston is moving upward, because of the vacuum created here, actually they are showing it green. Most of the gas will be going there. So the a little vacuum is created here, and the intake valve opens because of that. It opens automatically because of the pressure difference. and the gases incomes.
The second cycle starts. The hot air expands and presses the piston downwards, reducing the volume of the crankcase. Because of that, the mixture is forced into.
Now the pistons moves downwards, and this gas is pressured, and this valve will be closed because of this pressure. The valve is like uh, this, so it can open that way. It will can only open this way. So when the pressure increased here, it won't allow the mixture to go out. It will, so there will be the mixture should go to the transfer port to the combustion chamber.
The combustion chamber. At the same time, the fresh mixture forces the exhaust fumes out. Now the cycle starts all over again. The volume reduction in the crankcase can be very easily explained using small spheres. The spheres represent the fresh mixture. The mixture is sucked into the crankcase through the piston moving upwards. When the piston then moves downwards, no additional fresh mixture flows in and compression takes place because the volume of the crankcase is decreased. As a result, the fresh mixture makes its way into the combustion chamber via the transfer port. The engine shown here operates according to the principle of cross-flow scavenging. Intake and exhaust port are on opposite sides. The deflector piston is formed in such a way that the incoming fresh mixture can successfully push out the exhaust.
Here, this is also a main point. The intake and the exhaust ports are in opposite side, because for the pressure when we are giving by the intake gas, the exhaust should go out. If the exhaust port is near at the same direction, the gas remaining in the combustion chamber, the exhaust burned gas remaining in the combustion chamber will be high. Even though there will be a remaining gas in the combustion chamber in the two strokes, it will move when the intake port and exhaust port are on the same direction.
Neutral scavenging is another type of scavenging used. For example, in a post-piston engines, two pistons operate in only one cylinder. Here, one piston controls the fresh mixture flow, whereas the other controls the emission of exhaust fumes. This system is expensive and was used in tanks, but also frequently for large marine diesel engines. Modern engines use this loop scavenging, which is used, for example, in the famous Simpson mopeds. It is still used in many engines today. For the sake of simplicity, the crankcase and housing cover are not shown. There are various ports in the cylinder, including an inlet port. The fuel-air mixture is fed to the inlet port via the carburetor.
Carburetor is the part where the fuel and air get mixed together. Here for the two-stroke engines, we will mix the oil that is needed for the engine parts for the lubrication with the fuel when we add the fuel.
The piston, moving up and down in the cylinder, opens and closes the inlet port consistently.
Here the transfer port and inlet port and the exhaust port are opened and closed by pistons. Sorry, not the inlet port, the transfer port and exhaust ports are opened and closed by piston itself. But in four-stroke engines, we are using separate valves for that.
When the inlet port is open, a mixture is able to flow in. The mixture is then forced into the transfer ports by the piston. piston closes the transfer ports and exhaust port when it travels upwards. It opens them when it travels downwards. Through the transfer ports, the fresh mixture is promoted to the cylinder and filled from the rear to the front. When the spark plug finally ignites the mixture, the piston is moved downwards and fresh mixture is able to flow in. In this process, the fresh mixture pushes out the exhaust fumes.
Here, mostly the two-stroke engines are mostly spark engines, but there are some compression engine two-stroke engines which were used in marine and military purpose for to get even the power from a two-stroke is more high. To get more power, they have used a compression diesel engines in a two-stroke in marine purpose and in military purposes.
Yo, look.
This is the four-stroke.
Let's take a look at a single cylinder and see how a four-stroke engine works in detail. In order to ignite the air-fuel mixture, a spark plug is used. This will
Spark plug is the main component here. Yeah, four-stroke. Nowadays we are using compression four-stroke engines also. So for that four-stroke engines, we don't use spark.
ignite the
This is a spark used four-stroke.
fuel mixture with the help of an electrical spark. We will take it down by each stroke. The intake stroke, the inlet valve opens and the downward movement of the piston creates a suction. This pulls the air-fuel mixture into the cylinder. Once the air-fuel mixture is in the cylinder, compression stroke begins compressing the mixture. At this time both inlet and outlet valves stays closed. At the end of compression stroke, the air-fuel mixture is ignited by the spark plug. The explosion exerts pressure and pushes the piston down. This is the power stroke which produces power to the crank. At the exhaust stroke, the outlet valve opens and the piston pushes out the burned gas. The cycle starts again from intake stroke, keeping the engine running and produces power. For a carburetor engine, the air and fuel are mixed inside the carburetor assembly and fed to the cylinders. In the case of a fuel-injected engine, the fuel is injected into the intake manifold or directly into the cylinders. Since only a power stroke produces power, you may wonder how the engine turns continuously. Well,
So
the
that's all. It's
answer is in the crank itself.
the other thing
The
is
flywheel and the crank counterweights provides momentum, which keeps the crankshaft from stopping immediately. For a four-cylinder engine, considering any time instance, one cylinder is always in power stroke, which produces more power and less vibrations comparing to a single-cylinder engine. And that is how a car engine produces power in simple.
that is the main working principle of two-stroke and four-stroke. If I have missed anything, scavenging, stop, source, section, completion. Do you have any doubts here? So we can go for the pros and cons after using two-stroke and four-stroke. So actually, I also have that same comparison table. So we will quickly go through this comparison table. Okay. For two-stroke, and here it's the four-stroke. The the cycle means combustion cycle is one cycle, one revolution per cycle. Here, two revolution per cycle, but four strokes. Four strokes mean 4 times the piston is moving up and down. The power output is high in two-stroke because we are only getting for each cycle there is a power stroke. But for the four-stroke engine, when we see it, we see a four-stroke engine. For the 2 cycles, we are getting only one power stroke. So there will be a power loss. So the efficiency is low. Actually, the power is low in the four-stroke engine because the power loss is high. And power to weight ratio, when we consider about that, there are many parts in four-stroke engine, such as when we see it here, here we have to use an extra valves, valve springs, cams, camshafts, and there will be a timing chain for this camshafts, and these camshafts will be like overhead or below push rod camshafts. For those parts, there will be a little the weight will be gain more, and the power loss will be increased for that also. Because of that, the power to the weight ratio is low in four-stroke engines. And moving parts in two-stroke is just the piston is they are moving. Only piston is moving. Here, valves, cams, tappets, everything is tends to move. Weight of the engine, obviously, two-stroke is weightless and four-stroke is heavy. The fuel consumption. Here, the fuel consumption is high because when the exhaust stroke happens, the gas comes inside will sometimes go out because of the unburned fuel and air mixture going out. We are losing the fuel there, so the efficiency is low there because of that. Here, even though there will be a little bit like valves misoperation, otherwise there will be no escape of these gases in a four-stroke. Like lubrication, we are not using a separate lubrication for a two-stroke because the pore part is used for the combustion and intake and output. So oil is mixed with the lubrication. This make more wear and tear, and it will reduce its lifespan. For four-stroke engines, we are using a separate can for the lubrication. When you see here, we are using a separate lubrication can, and that lubrication liquid will go through everywhere. So when we consider about the environmental pollution, the unburned fuel and that oil we are burning with the fuel in two-stroke, it will cause more carbon to emit. So it will cause environmental pollution more. And durability for the two-stroke is shorter because of we are not using any lubrications. It will, when the parts get heated, it will move get dilated or wear and tear, and because of that the lifespan is low. And this can rev at high RPM also. Two-stroke engines actually, because of the strokes and only two for a single power, the revolution is high. Because for the four-stroke, for the other three-stroke, we are using the energy gained from the four-stroke, which is stored in the flywheel. So actually, we are using this flywheel to store store some energy that we gained from the power stroke to activate other cylinders or activate other 3 cycles in a four-stroke engine. Because of that, there will be a its RPM will be low. And applications, it's mainly used not it's like from 1935 to 2000 something, 2000 maybe 85, 1985, the two strokes are used most. After the four stroke, it has reduced, but applications are now lesser. Uh, Maintenance is simple for the two stroke. That's a little. It's complex because of there are many parts to maintain and do it correctly. Stroke length cycle. Okay. Here, the stroke length may be differ. We can't just say it's shorter distance by when we consider about the ship vehicles, ships and other tanks. The stroke lengths are high, so we need high RPM. So for those diesel engines, the stroke length is longer. So uh, flywheel recommend. So here in two stroke, we don't need a such a flywheel actually, because with the reaction force gained from the power stroke, we can compress the gas easily. But for the four stroke, we need actually the flywheel to maintain the motion and to do the other strokes. These are the main comparison. So if we come to how to identify these two's. Mm, stroke engine. Okay. Mm. So how can we actually identify these two-stroke and four-stroke engines when we see from outside? So when you see actually the intake port will be lower and the exhaust port will be higher. But in a four-stroke, it will be at the same height of, yeah, it will be at the same height mostly. And when we see outside, there will be a separate uh, port for the engine oil. In four-stroke, we don't see such ports in a two-stroke engine. Mm. Other difference we can identify, we don't have actually the spark plug will be at the top. Here the spark plug will be at side or something in between the ports, because there are valves, cams here at the top. We have to insert these valves and cams. Because of this, the spark there is no space for the spark plug. It's actually mounted sidewise. Oh, it will insert it fully inside that. Are there differences from the two-stroke and four-stroke? Mm, Any difference? We don't use oil in four-strokes with the fuel. Yeah. That's how we identify two-stroke and four-stroke. And that's engine configuration. Do you have any doubts in this two-stroke and four-stroke comparison? Anyone? If you're having any doubts here, you can ask. Then the next will be different configuration of engines. If there are no doubts, we will go to the engine configuration. So I'm audible, right? It's clear, right? If you have any doubts, ask me. So for this engine configuration, we just actually know how the engines are placed and how that is the placement of the pistons are called this engine configuration. So there's nothing much here, just to know how to identify these engines. If the pistons are in parallel order, that's called inline, and it's easy to maintain and manufacture. The number of cylinder is actually limited to maximum will be six, inline six mostly. If we increase the length, we don't get enough space for a engine bay actually. The flat engines called like boxer engines, where the pistons are horizontally opposite each other. Here, the center of gravity is low and wide. We need a wide body kit for it. When the engine is at V position, yeah, if the engine is V, that is called the pistons are arranged in a V position. That is called V engine. That is also categorized as V60, V70, V65, V90, like the angle between the V also. That's not V. And W engines means the three pistons or four pistons in a V position. That is W engine. Here, the crank is in between W, like it's not actually W. The little bit like that. The crank will be at the middle, and the four cylinders will be at the corner of each, I think. And rotary engine is actually used in Mazda also. Here we don't use any piston. The engine that don't have any piston is this rotary engine. We can identify it easily because there is no piston. This crank will moving crank like structure is the actual piston that's doing this work. And radial engine means it's a circular engine. You mostly used in aircrafts. It's like modified by, but this engine is mostly used in aircrafts only. So that's all with the engine configuration and engine, how the engine works. Do you have any doubts here with layouts and combustion? But we have gone through this. So first, I have included everything in these three chart, the two lecture slides. So it's easy to for you to go through from these. Front wheel, engine layouts, then spark ignition and compression ignition, and then two-stroke and four-stroke. These are the main things for from these lectures. Uh, shall we move to the ignition and cooling? So in 5 minutes we will go for the ignition and cooling. So actually that part is little bit high and need. So we will continue this ignition in a 5 minutes. So. Okay, guys, shall we continue? Am I audible? Ketulah. Hello? Am I audible? Ketulah. Shall we continue, guys? So, here comes the main part. From this, we have to go deeply. Those two are nothing much for that. First, for an engine, we needed ignition system to run the ignition. That is where we are going to do the running of the engine. So, the main importance of the ignition system, we need the system to control the ignitions of if it's a multi-cylinder or single cylinder. We have to keep the engine rotating to get a continuous power output from that. So, the main reason is to ignite the fuel and make the power. And we have to reduce the emissions also, improve the fuel efficiency, and we have to stop engine knocking, reduce engine knocking. Actually, if the engine knocks, actually we are not going to get enough power. And classification: spark ignition, compressor ignition. So we are going to go through a spark ignition system. Spark ignition actually also said air and fuel mixture is sucked, and at the compression stroke it is ignited. Then with the spark, here the main part is the spark plug, and here comes the electricity, which we are going to ignite the fuel with the electric spark. So functions, when we see about the functions, spark ignition system means the functions like we are giving us spark for the fuel mixture at the correct time. That is the main thing here. So we'll go through the parts. This is the basic parts for this ignition system. So we need a battery. So in some bikes or other, if it's a four wheel or more than that wheel, we usually have a battery for, and if it's a bike, we usually use a magneto, just like a generator inside the engine, so we can kickstart it and do the thing. Or in Landmaster, we don't use battery also. The ignition coil. The ignition coil is like a transformer, but which converts the low voltage to high voltage, because we are going to create a spark with the voltage difference. Actually, the scene happening in a lighting like that, lightning. So the ignition coil is the thing that makes the 20 volt into 20,000 volts for the spark plug. Here, this is the contact breaker and this is the distributor. Actually, this distributor and contact breaker are included in the same cylinder. Actually, the distributor at the back of the contact breaker, or contact breaker will be back of the distributor. This joint and this cam lobe will be directly connected to the camshaft. Camshaft means here this is the contact breaker scenario, and this is the distributor thing. Distributor thing, and everything is connected in the same shaft, and this same shaft will go to the that is that this shaft. This shaft will be go to the camshaft of the engine. So if we take Yeah, we can see here. Ah. Mm. So this is not actually a cam engine. Wait a minute. So this is the camshaft. That distributor will be connected to this directly. So here here is the distributor. This will be connected to thoroughly with the camshaft, and this camshaft is driven by the driving belt that is connected to the crankshaft. Here, that's crankshaft is not here. This is the crankshaft. This will connect with the timing belt, and the timing belt will be connected to the camshaft. Uh, the next main thing is here the capacitor. We will go through every use of the parts here. This is the contact breaker, and this is distributor, the points. We can identify the how many cylinders in this engine, like we are like seeing this cam lobe. This is actually called as cam lobe. This is the thing that is we called as cam lobe, and the thing that above the piston, above the valve of the piston in a four-stroke engine, that's also we call that cam lobe. Here, this thing also we call this as cam lobe. Then we'll go through the every usage of it. Screenshot தெரியுதானே? Okay. Okay. So we'll go through how it's work. So when we connect the circuit, actually the minus will be connected to the body of the vehicle usually. So the main reason to connect the minus to the body is actually to reduce the wiring system. If we are using a separate wiring to that, the for every parts the wiring will be more long. So to reduce that, we are actually using the minus part as the ground of the body, and the wiring starts from the plus part of the battery. It's going from the battery to the ignition coil and to the contact breaker, and the contact breaker is connected to the minus point. That's basically ground, and this capacitor also basically ground. And here the spark plugs grounds are connected to the body of the. This will be connected to the distributor cables that will come outside of the engine. Yeah. This is the distributor cables for the each spark plug, and the spark plug. Yes. The spark. This is the base of the spark plug. This base will be connected to the body of the vehicle. Body of the vehicle means engine. Engine is connected with the body of the chassis. So it's everything is ground there. So this will be ground, and this main thing is connected through here to make a high voltage difference. So if we go through the functions of these parts, So the first part, ignition switch, we have to connect the switch first. Then the ignition coil. That ignition coil is it's actually step up transformer, but we are using DC here. The batteries are DC. It's here like it's stated as AC, but we are not using AC current here. We are using the DC, and we are getting an voltage fluctuation by disconnecting the circuit. So in video, I will show it more clearly. So here actually the circuit is not AC. The circuit is actually DC. We are making it as AC to make a voltage fluctuation and to make the secondary voltage difference. And the third part is contact breaker. Contact breaker actually do here the contact breaker thing. From the coil, it will come to the contact breaker. Contact breaker means the point where the circuit is breaked. So for every cam loop point here, this circuit is disconnected. From this disconnection, there will be a voltage induced here. When we connect the coil through a circuit, this circuit is completed first. So there will be a magnetic field around the coil. When we disconnect this circuit, the magnetic field tends to reduce in an opposite direction. That reducing magnetic field will create a EMF current in the secondary coil, this small coil. That will induce that is the voltage that goes to the spark plugs. That is the current voltage that goes to the spark plug. And here, when the contact point is braked, there will be a EMF because of the magnetic field reducing. To protect that contact breaker, we use a capacitor. So actually, when you see the videos, it will be more clear. Yeah, we'll go to the videos. That will be easy for you. See the video. If you're unclear, ask me about what is unclear about here. So now the circuit is fully connected because the ignition switch is on. The current is flowing through the coil. Videos. I think we know the video sound. Now the circuit is completed. So the current is going in a flow. When the current goes in a flow, there will be a magnetic flux created around this coil. Okay. Now we are going to start the engine. When we start the engine, we will rotate the crank. Actually, we are going to rotate the crank. In vehicles, we are using starter motor to rotate the crank first. So when we start it, the cam load is going to rotate. When it's rotating, because of these elevated points, the contact is going to break. This is called contact breaker. When the contact breaker is breaking, there will be an EMF magnetic flux decrease in that coil. When we see the coil, when the contact breaker is break, the magnetic flux here will be decreased. So we need, if we are having 6 cylinders, we need a 6 point cam low. So we need to break the contact for 6 times for a single rotation, because we need 6 spark plug to fire. Now you see here, here the circuit is fully connected, and there is a magnetic flux here. The red part here shown is the magnetic flux shown here, and the magnetic flux will be created when the circuit is completed. When you little bit, all right. Here the contact is break here. When the contact is break, the magnetic flux start to decrease. Because of the magnetic flux is decreasing in an opposite direction, there will be a current induced. The current will be induced in both primary and the secondary coil. Okay, we'll come why the reason for the condenser here. Here it's connected here. The circuit is completed. When it's calm here, see here, when it's calm, the contact is break and the magnetic flux is reducing in an opposite direction. That is creating an EMF to create a current flow in the secondary coil. And this current will also flow in the primary coil also. Current will. It's breaking. Here we also because it's going, contact is going to break during this part. Will come here now. Here. Here the yellow line indicates the circuit is completed, and the red lines indicate the EMF current produced by the magnetic flux. Okay. When okay, now the contact is break here. So when the contact is break, there will be an EMF produced because of the magnetic flux reducing. When the magnetic flux is reducing, EMF produced, the current will flow in both secondary and primary coil. So the current flowing from the secondary coil will this from current producing from the secondary coil will go to the spark plug distributor. But the current flowing to the primary coil will come to the contact breaker again. If the current comes here, because of this small gap, it's like because the spark tends to jump there. When the spark tends to jump there, that will damage the contact breaker. So in like when you see actually these are used in two-stroke bikes. Like if you know about RX100, Yamaha YB100, those bikes have this problem because they don't have a condenser. They only have this contact breaker and the points. We actually need to clean the contact breaker frequently. Like every 2 or 3,000 kilometers, we have to clean the contact breaker because of this problem. Because of the back EMF, spark will go through and it will damage the contact breaker and make a carbon or some carbon or little, and because of the dust and other things that will burn it fully around the contact breaker and it will not spark the plugs. So to prevent that EMF going to the contact breaker, we use the condenser to absorb the back EMF here. This absorbed back EMF will be transferred when the circuit is completed again. So you see, when the when contact breaker comes here, the back EMF is absorbed by the capacitor, then it is released, then it is now released when it tends to complete the circuit. Okay. This is the main use of capacitor. It will be little confusing why the back EMF coming and going. Is it clear, guys? So this is something main here. The main use of the condenser here. Okay. You can go through. If you're a little bit confused, ask me. If anything confuses you. Then now the voltage is transverse to the distributor lobe. This lobe will also rotate with the camshaft, and the points are here for the each spark plug with the distributor cap cylinder. When it's touches nearly, it will touch it nearly. It will give the current to the spark plug, and the spark plug will create a spark inside it. The spark is created because of the voltage difference between the ground point and the spark point of it. Yeah, actually, the air column is ionized here and the spark is created. The current comes. This is the ground electrode. This ground electrode is connected with the body of the vehicle. This will create a ionized air gases and it will create a spark. So do you have any doubts in here? How it works? Right. That's how the every cylinder is ignited in individually. Then basically contact breaker, capacitor, uses capacity, distributor, spark plug, gas image, okay. Spark timing. Then the timing is now here an important thing. Shall we continue the spark timing with it will go a little more with the centrifugal advance and vacuum advancing. Shall we continue now or shall we continue in another class? So it will be a little long when we are going. Now. Okay. Then we will post this here until the with these parts used. We'll go with the spark timing next class. So if you have any doubts here, you can ask or you can message me also. Anything here? This is like now just a start. So nothing much here. If you have any doubts in comparison of those and in the spark starting, you can ask. Actually, remember all the parts and engine parts and these everything. So, yeah, there's actually parts labeling questions in every paper. So actually, this ignition part is will be a single full question, I think. You have any doubts, so we can wind it up. Then message me if you have any doubts. Okay, then we will stop it.